And now we're recording. Great. Okay, so now we just already start to see the participants coming in. So here we go. This is our third annual TMM. I was writing about this on LinkedIn this morning, and I was like, when we started the TMM 3 years ago, we were just testing something out. We wanted to see if this would work, and if it had legs. It's got legs, it's got a torso, it's got arms, it's got a head.
Yep.
It's got all that.
All them parts.
All the things.
We're looking at over 100 of your peers joining you today. And I was telling the team that I'm down in Ponte Vedra and the Tournament Players Championship is happening. And I had a dream last night that Mike and I were, and Kalia, were doing this with our golf announcement voices. And now the newcomer to this year.
Lining up
For
his hole-in-one.
Can you see my screen? I just want to test the screen share.
Yeah, I see it. Okay.
Yep. Looks great.
And I think that if there's one thing that we're not at Great at Data Mines is quiet like that and reserved. I feel like that's not anybody's style.
I don't think so either.
We're the opposite of that. All right, we got Francesco kicking off the chat. Thank you, Francesco.
Oh, Francesco.
Hello, my friend.
Hi. Hello, our friend.
Awesome.
Hello. I hope you're going to spend the evening with us because it is starting to be your evening. So
Francesco's probably already on his wine. We're still on our caffeine.
where in the world is Francesco?
Francesco's screaming at you, Julie.
Are you in Poland, Francesco? Oh, good. Wow.
Yeah.
Yeah.
All right, well, I think we should just, let's just kick things right off because I see the attendees are flowing in. And so I would just like to welcome everybody to our third annual Technology Matters Marathon. My name is Kalia Garrido. I head up events and marketing here at Great Data Mines. We have our co-founders and chief troublemakers. Julie Burrows is our CEO and Mike Lampa is our chief analytics officer. And I'm gonna keep it simple because we've got a lot of groundwork to cover today. So, let's get right into it.
All right, Kalia. So Julie, our first guy is up at SingleStore, and I find this a very, very compelling technology, and especially for anyone that's trying to work their way through modernizing their data platforms, fully managed, real compelling total cost of ownership, multi-cloud, and another thing that's really kind of cool about it, it can do real time, it can do batch, it can do change data capture, all the cool things that when you do, and I don't need a separate ETL tooling product. That's pretty cool, I think, Jules.
That's pretty cool. As you see these guys, I've learned about them through a wonderful woman by the name of Julie Price, and she was the big query queen for a long time over at Google. And I'd listen to her talk about BigQuery and everything. And all of a sudden she showed up here and I'm like, what is this? And now we're starting to see SingleStore in the media more and more. And, game changer is what we think of you guys as. So we're really excited. This is the first year that SingleStore is with us. And hopefully we'll see them in years to come. But these guys are a force to be reckoned with and someone to watch. So yeah. Hey, really quick, Kalia, we need to go ahead and tell everyone if they've got questions, put them in chat. And while we're in chat, we're going to be adding any information, pointing you in different directions. And please ask questions in chat. We'll bring them to the forefront. Or if you think something's cool that you see, go ahead and say, that's cool. So let's get that chat going out there and let's get moving.
Alrighty.
And we'll save a couple minutes at the end of Rick's presentation and all the presentations today to have sort of a more formal Q&A session in which we can unmute people if they really want to ask their question live. Like Julie said, use that chat. We can also field questions via the Q&A. We use that less because if you put it all in the chat, then what we find is that our participants will answer each other. And that's right. The magic really happens. So that's what I encourage it.
Great. All right. With that, I'd like to introduce Rick Negrin. Rick's the field CTO at SingleStore. Welcome, Rick.
Thank you. So I'm the field CTO at SingleStore. I've been at SingleStore almost 6 years now. So I'm one of the guys who's been around the longest. Before that, I was at Microsoft and the SQL Server team. So I spent quite a bit of time in the database world now. So I'm going to go through a bit of a presentation, kind of give you an idea of what SingleStore is, and then we'll jump into a demo and show you how it works.
Okay, and Rick, we're going off camera so they can focus on your great face.
Okay.
And good luck.
Thanks.
luck, sir.
And you can see the slides.
Yeah,
Yes,
they look
sir.
great.
Yep.
Great. Let's get going. So to set some context, right? Like the thing we saw in the industry as we were looking to build SingleStore was that businesses were becoming more data intensive. And what do we mean by data intensive? We mean the data volumes are rising exponentially. That's been happening for years, and probably no surprise to anybody on the call. But also the complexity of the data is rising. By complexity, I mean the data sources we're getting data from are more varied and more complex. The formats that data is coming in have exploded into a number of different formats. The levels of quality of the data coming in. And so the amount of work it takes to wrangle that data into a shape that you can actually get an insight from and take action on is getting harder and harder. The other aspect is that people expect things immediately. And so to give an example from a sort of a personal example, it wasn't that long ago, maybe 15 years ago, maybe as recently as 10 years ago, when I wanted to know what was in my bank account, I would get a piece of paper in the mail once every 30 days. And that was good enough. And I felt like I was informed. And you fast forward to today, and if I swipe my credit card at the grocery store and I don't immediately get the transaction in my banking app, I'm assuming something's broken, I'm angry at my bank and thinking about switching to someone else. So people's expectations for timeliness, for having information right at in the palm of their hand instantly, has just gone up dramatically. And that's something that shows up in the enterprise and the company world as well. That all the employers expect all their employees to have access to instant data and using that data to make the best decision possible in every moment. And so we're seeing sort of a maturity curve, right? An evolution of how people think about data and analytics from what we call the historical model, where you're looking backwards in time. Tell me what happened last quarter, and then I'll run a report so I can decide what to do this quarter. To tell me what's happening right now and have all my employees using that data to make decisions. But it doesn't stop there, right? That the next step is then, well, don't just tell me what's happening right now. Tell me what's going to happen in the future so I can take advantage of a new opportunity or avoid a problem. And then the final stage is take that prediction, feed it back into my operational systems and make the decision automatically and just take the human out of the loop altogether. And if I was to draw a bell curve over this model, I'd say most people are still trying to get from historical to real time. That's where the majority of our customers are, is people struggling to go from first step one to step two. But we do see a long tail of people who've gotten further ahead and are starting to do the predictive and AI pieces as well. Now, the challenge, of course, is that the infrastructure they have was not built to meet these kinds of requirements. It was built for the batch 9 to 5 days when you did stuff during the day and you could do stuff at night when the system wasn't running. We don't live in that world anymore. It's a 24/7 world. You have global spanning corporations and companies. And so what they need is the ability to instantly move the data, right? You want your time to insight from the time a piece of data is born to the time you can get an insight and take action on it. You want that to be as close to zero as possible. But we're finding many customers struggle to they have latencies of minutes, hours, sometimes even days before they can move that data through and actually to make use of it. And they're unable to meet the SLAs that they're trying to meet in order to succeed in this world. And so when they try to take the existing infrastructure and make it work, one, some of it just struggles and can't do it. In some cases, they can barely meet it, but the cost and the complexity of the infrastructure, it just gets untenable. And then to throw more gas on this fire, right? You're not just trying to meet the needs of before in terms of the number of people using the system, right? In the old historical world, you had a small number of analysts, right? Maybe single digits, working in a back room to run reports whenever you needed them. And in today's world, though, you're trying to arm every employee. So you're now going from maybe 10 or small tens of analysts to hundreds, thousands, tens of thousands of employees for a really big company, all slamming those data systems. And they weren't built for that. And so they tend to fall over and hit bottlenecks. Take it one step further, right? You want to expose your data to your customers and your partners. Think about every bank puts a mobile app in the hands of their customers. You have hundreds of millions of customers all hitting that system, millions at a time. The standard infrastructure that people have just won't work. So that's why we built SingleStore, was to be the single database for these data intensive applications. And what it does is it combines the operational capabilities of an operational database, right? Be able to do fast lookups and fast inserts and updates and deletes and have the resiliency and availability and durability of those systems. And then combine that with the power of an analytical system, ability to do fast queries over very large data sets, do large data aggregations, high levels of compression, and bring all that together into a single system to serve the needs of these apps. And it's all powered by our patented technology of universal storage, which I'll talk more about in a minute. So I keep mentioning this concept of a data intensive app, but like, what does that mean? Let's break this down a little bit so it's a little bit clear how we define what is or is not a data intensive app. So intensity is defined in physics as power over surface area over time. And so it's not any one of those dimensions that matters the most, it's the combination. So data intensity is the same way. It's a combination of a set of dimensions. And when you've got high requirements in 2 or more of these dimensions, you start to run into this concept of data intensity, right? So the dimensions are how big is the data set you're operating over? How fast are you trying to bring the data in, right? How many thousands or millions of rows per second do you need to push into your system? What are your latency requirements? How fast does the data have to come out? Right? If you're powering an interactive user experience, you really want sub-second queries, or your customers are going to be sitting there waiting. How complex are the data sets you're using, and have to join together, right? So sort of measured by the number of joins of those data sets. And then last, but probably most important one, is concurrency. How many users are trying to hit the system at the same time, right? How many queries have to run concurrently and still meet those latency SLAs? So when you find that you have 2, and especially if you have 3, 4, or definitely 5 of these dimensions that you have high requirements in, then you're running into a data intensive problem, and you're going to struggle to find a data infrastructure that works better than SingleStore. So let's walk through some examples of sort of what are the workloads that people are using SingleStore for. So the first one is customer experience. And by this we mean anybody building basically a SaaS app that they have to give to their customer or partner or the person typically outside their company. And the reason that matters is that usually means there's an SLA associated with it. Even if it's not an explicit legal agreement, there's an expectation of it will be fast, it'll be available, and it'll always be there when I need it. And when it's not, the customers get upset and they leave, and that causes churn, and it's bad for business. So being able to deliver speed and be able to do it at high concurrency is pretty critical, especially when it's a fast growing app. If your business is growing, you need an infrastructure that will scale with you. And this allows you to then drive new revenue streams, having engaging customer experience, which keeps your customers happy and keeps them with you and can help you manage your growth. The other workload we see often is measuring business health. So when you have a business that relies on a lot of data, so any sort of manufacturing or any kind of logistics type company, a lot of the fintech, there's a lot of these companies where there's a lot of data about their business, about the running of their business, and media and MarTech are also good examples. And so when there's a lot of information about how the business is running, you have to bring that together and understand the health of your business. And you need to do that on a reliable basis, and it needs to be up to date. You can't afford to wait 2 days to find out what the state of your business is, or you won't be able to make the right decisions. And so being able to bring all that data together, get it to the right quality, get it into the right shape, and then surface it in a way that's interactive and up to date has been a big challenge for a number of these companies. And so people use SingleStore to then measure the health, to be the nerve center of running their business. So let me give you some concrete examples of what this looks like. So Uber is a good example of that customer of the more business health experience, where the employees at Uber have a dashboard that allows them to know what's going on in their system and make decisions about, do they need to deploy more drivers? Do they need to do surge pricing? Like, do we need what they need to do? And they need to bring together, and they clearly hit high requirements in most of those data intensive dimensions, right? They have large data sets that has to be in real time, right? When you book that car, you want the answer in seconds or at most minutes, right? And they have that happening around the world, right? Thousands, millions of people hitting that button. They have to bring all that data together, and they have to bring the data about the drivers, about the users, about the traffic and the municipality rules, compute an answer and get that back out to that customer. And they need to be able to do that instantly and not have to wait. For our customer experience, we have the credit card fraud analytics. So we have a large bank, unfortunately not allowed to use their name, but if I named it, you would recognize it. They're one of the top 5 banks in the US. And they had an experience where they wanted to be able to run a model and try to detect if a credit card transaction was fraud or not, and do it before the transaction completes. So that means when a user swipes a credit card, you typically have about a half second before a human notices any sort of delay. So that's about 500 milliseconds. So they had 500 milliseconds to do a round trip, pull out all the information they needed about the user, run it through the model, make it relative to the transaction, make a decision, and send the answer back. So they allocated 50 milliseconds to the database to be able to produce that information. Now they had a system of about 14 different open source data stores they're trying to use to do this. And it was taking minutes to run the queries and was not able to meet this idea of being real time. And so they're having to go and claw back the transactions after the fact because they couldn't do it fast enough. And they replaced all those data stores with SingleStore. And they're easily able to do all their queries in less than 50 milliseconds and meet that SLA and start doing real-time fraud analytics. I'll just do one more and then we'll move on so we can get to the more interesting stuff around the demos. So the energy company has all these smart meters, right? Smart meters measuring the energy usage in their house. And what they want to know is they actually use it for a couple of use cases. One is to do preventive maintenance. Are there any devices or machinery sort of in the network that might be close to failing? And it turns out if you watch the energy meters on the houses and the commercial locations, you can start to see patterns from the fluctuations that will indicate that something's about to fail. And that allows them to then detect that, predict the failure and then roll a truck out to go fix it before there's a failure and an outage causing people to lose power to their house. They also use it for something I didn't even realize, which is energy theft. Apparently people cheat and they will run their wires around their energy meter and try to steal energy. This is probably a big problem. And so they are tracking in real time what the usage is in the meters. And again, they can run models on that data to detect, is there a problem here? Does this look suspicious? Should we send someone out to go check it out? So SingleStore powering a number of different types of data intensive apps in the logistics space, financial space, energy space, all over in many verticals. So what allows us to do this, right? There's a lot of databases out there that all say they're fast and say they're efficient. So what's our special sauce? What makes us unique? So as I mentioned, we have this feature we call universal storage. It's basically a single table type that can be both transactions and analytics, right? Give you the capabilities of both types of system. And we built that on a distributed storage system. So the beauty of having a distributed system is that if you need more power, you just add more nodes into the cluster and you can scale it out as you need it. And we built universal storage because we felt the trade-offs between row stores and column stores were too harsh. People wanted to have the combination, the power of both. And for a long time, the industry believed it wasn't possible, but we proved it wrong. And then we coupled that with our underlying storage model, and we built something called unlimited storage, which is our version of separation of storage and compute, which is what allows us to run the cluster with the local storage, but also have the data backed by an object store. And the advantage of coupling an object store with the local storage is you get the low TCO of storing things in object store, but the low latency operations of a local SSD. And the system automatically will move data back and forth based on what's going on in the cluster to optimize so that your hot data is always available and ready for you, but the colder data stays in object store and gives you a better TCO. And then one of the most powerful features, and this is something I'm going to demo in a bit, is a feature we call pipelines, which I think he alluded to earlier. This ability to load data into the database as a native feature built right in the product. And it's really easy to use. It takes advantage of the fact we're distributed to do parallelization so that the more nodes that you have in the cluster, the faster the ingest will go. So you can scale your ingest just like you scale the rest of the dimensions of your app. We're multi-model, so not only are we a familiar traditional relational database, we also support just about any data type that you might want in the system. So we have native support for JSON, if you want to treat us like a document store. We have support for key value. We have a native geospatial index, which you'll see in the demo. We support time series with all the SQL time series functions, and we have a full text search engine built in. And all of these are built in a way so that they're all part of a single API. You can write a single relational query that incorporates all of these aspects without having to have complicated and different APIs. And in terms of how we deploy, we have both a managed service, which you can run on any cloud, AWS, Azure, or Google, or you can use our software and deploy it in your own data set. And we fully support Kubernetes if that's your infrastructure, or a VM or bare metal work as well. And last but not least is compatibility. And this has been pretty important to our customers, is that we're ANSI SQL. So if you know SQL, you know how to use SingleStore. And in fact, we're wire protocol compatible with MySQL. which allows you to use any of the tools in the MySQL ecosystem. So all of the BI tools, the programmatic tools, the replication and ETL tools, they all just work with SingleStore because of that compatibility, which has been pretty significant for our customers. Okay, so that's the slides. So now let's head over and see how this all works. So what I'm going to show you is sort of what it would look like to build a real-time digital marketing application. As I mentioned, MarTech is a fairly common use case for us. And why is digital marketing a common use case for us, right? So if you think about what makes up a good digital marketing thing, it needs to be fast, right? You want to have fast interactive analytics that tell you what's going on so you can correct things as you go. It needs to handle lots of data. There's often a lot of different data, especially when you're trying to deliver things. It needs to be real time. Often there's a SLAs attached or time windows in which you can act before the opportunity goes away. And the queries are often complex because they're over fairly complex data sets. So the idea around this demo was, imagine you had to serve ads to users based on their behavior, like past behavior in recent past, and their location, right? So imagine you're a cellular company, for example, and you're handing out cell phones to people and say, look, we'll give you the cell phone for free as long as you're willing to let us track your web searches, your purchases, and your location, and let us serve you ads. But you can imagine applying this kind of pattern to pretty much any of the digital kind of marketing scenarios. And so what you're seeing on the screen now is not quite the app itself, which I will show kind of the dashboard at the end, but the steps you'll go through to build an app like this. So what you can see here, I've got this URL here in this tab. This is my cluster. It's a single 1-unit cluster, which is about 8 CPU and 64 gigs of RAM running in our managed service. And so it's running, but nothing. It's like totally empty and not there. And so the first thing I need to do is I need to set up my schema, right? Set up the structure of how I want to store the data. So I'm going to click the Set Up Schema button, and it's going to create the database and go create all these tables. Now, what tables is it creating? Well, to set up this situation, I need to know who all the subscribers are. That's my subscribers tables, the list of users. I need to know all the web searches they've done. And the demo gods were not happy. There we go. All right, everything's working fine. I need the list of web requests. I need the list of purchases, right? So that's my request table, my purchases table, subscribers. So I know who they are and I know what their behavior's been. I also need to know their locations, right? Where are they right now? So this tells me if this table is basically being populated as if the user is walking around and in a given location. And then I need to know the offers, right? This is from the different companies that want to put in offers that of which I'm going to serve. So like a coupon for 5% off Starbucks, for example. And then there's the notion of segments, and segments are basically the criteria for, given someone's past behavior, should they get this ad or not? So now I've created all these tables and everything's going. So the next step is you need to load all that data into the system. Now, in some cases, right, this would actually be coming from real devices. We're simulating that using our pipelines feature that I mentioned. That's actually ingesting this data from S3. And you can already see that I've got about a couple of million of rows loaded into the system here, and it's going to continue loading those as we go through the demo. So it's loading the requests and the purchases, and then the locations. Now, the next step is I need to load the offers, right? So now I've got all these companies, right? This is the supply side, right? I've got my demand side on the right, and then the supply side is the offers that need to be loaded. And each offer has a maximum bid price and an activation zone. So I'm going to load those offers. So you can see a nice visual here, and I'll zoom in. This is a visual of New York City. And each of the blue squares represents an activation zone, a geographic boundary that we've mapped out in our database using a spatial longitude and latitude set of points. And anytime a user walks through one of these locations, they'll get the offer then attached to that location. And if there's multiple offers for a given location, we'll actually look at the bid price and decide who's got the highest bid and serve that ad so the user doesn't get too many notifications. And so you can start to see now, right? I've got a complex set of tables. I've got people walking around and things happening in real time, and I'm having to go and join all that together, run fairly complex queries that have to return pretty quickly, so I can determine what is that ad that I need to serve and serve it to the user before they walk out of the location and get too far away for it to be relevant. Right. So now we need to do the matching subscribers to segments. Remember, segments are the criteria, right? How do I need to know, is this user bought coffee in the last day or not? Because if they haven't, then it's not as relevant to send them a Starbucks coupon, right? Or have they purchased something to do with bikes? So maybe if there's a bike shop nearby, we'll offer them a tune-up on their bike. And so I just ran this query, the select from dynamic subscriber segments, and it basically evaluated the 5 million rows of the subscribers against the 872 segments, the criteria, and we determined now there's about 2 million opportunities to serve ads. But we can't serve them yet because we only serve them if the user is actually walking through the location. These are the potential ads I could serve. And that whole query took about 4 seconds. And so the last thing is we need to then generate the notifications, right? And so now we need to match the offers that we have figured out to the subscribers based on their location. And so if I generate notifications, this query basically will do that match and then determine if there's any notifications to send. So let me show you what this looks like behind the scenes. So I mentioned, right, I showed some of these queries, the selecting from the dynamic segment subscriber segments, right? Hold on, I'm in the wrong cluster. So what I'm in here now, this is our SingleStore Portal. This is how you interact with the system. So you can see I have my list of clusters over here. My cluster I'm using that I had hooked up to the demo is the S1 cluster here. S1 is the size of the cluster. And I'm going to go to the MarTech database. So now I can run this query. And I get back which city I'm in, the subscriber ID, and all of the segments, which is that criteria, right? Or I can also match offers to subscribers, right? And this is doing that match to look for notifications. Now, one of the cool things you can do in the portal is you can do things like profile the query. And I'm having a demo error. Try it again. Right. So what this tool does is it lets you drill in and actually get a handle on what does the query profile look like. Now, in this case, we've already optimized the query, so there's not much optimization to do. But I'll actually tell you where the most time is spent, and you can see a lot of the time would be spent here on the projection, which is what you want for a query like this. But this tool is very powerful for then navigating and figuring out, what are the best queries that, what can I do to optimize this query, where is it spending its time? And to give you a sense of what that query looks like, this is what the matched offers to subscribers query looks like. And, you can see it's not a simple query. It's doing a number of subselects, and it's joining the subscriber's last notification to the notifications table to the subscriber segments, right? And the number of matching segments. So it's doing a like 2, 3, or 4-way join, and it's doing it, but it runs it all in less than a second. So over millions of rows. And this is a fairly small data set, but you can easily scale the cluster to handle larger data sets as you go. And so we also have other features in the portal. For example, you can do a drill down and see what the database looks like. So I'm going to choose the MarTech database. I can see if I select it here, it'll tell me, right, how many tables there are, roughly the row count, right? I've got tens of millions of rows in my request table, which is the most common one. You can see the rough size. This is with our compression of both the disk usage and the memory. And you can see the tables and the different types of tables that I have in the system. Cool. So that's the MarTech demo, showing how we load data, right? How we query data, how we handle the data intensity of a MarTech application. So the other thing I want to show is the pipelines feature. So I've been mentioning this pipelines feature. This is how we load data. I'm going to scroll down here. So I've set up another demo, which is how can I load data quickly in the system? So I'm going to switch over to these two clusters I have, my S8 cluster. And I'm just going to start this pipeline here. Got to use the database first. So I'm starting the pipeline. I'm going to do this in two different clusters. I have my S8 cluster and my S16 cluster, and I'll explain what that means in a second. So I'm now in my S16 cluster. I'm going to start that pipeline. So let me go back and explain what's going on. So what I've done is I created a database called the fast load database. And I've got a single table called trip info. Trip info has three columns: a distance, duration, and the vehicle ID. Right? You can imagine what this represents, right? How far this vehicle is going. So fairly simple table. I'm admittedly doing it simple to make it easy. And I've got a sort key, which makes it easier to sort and run queries on across this dimension. But the important part here is this create pipeline statement here. And what this does is this creates what's called a pipeline, which is a SQL object in the database, metadata object. You tell it where you want to load data from. Now in this case, we're loading from S3. So I say load data from S3 and I give it the URI of the S3 bucket. Now we can also load from other object stores, Azure Blob or Google GCP, Google's cloud storage, as well as queuing systems like Kafka. And then I say into table trip info. That's basically means load that data into this table that I have up here. And then I tell it, how the fields are terminated. Just in this case, it's a CSV, so I put commas. Now I'm also able to do lightweight transformations by doing a set statement. In this case, I have the data in minutes in the file, but I'd like it to be in seconds when I put in the database. So I can just multiply that number by 60 and that transforms it. Now you can do more complex transformations by actually, instead of doing it into a table, you can do it into a store procedure, and then you can write more complex logic in a store procedure. Now, of course, that'll have performance impact, but you can easily do that. And as you'll see, we have plenty of headroom to manage the performance. And then once your pipeline's created, you say start pipeline, which is what you saw me do earlier. So the pipeline started, and we're going to check and see how it's doing in just a moment here. And so what's happening is basically every node in this cluster, and in an S8 cluster, there's going to be 8 nodes, and all 8 nodes are pulling in parallel down from the S3 bucket and loading the data. So I'm going to run this query here that actually is going to go over our information schema, which is our metadata tables, to see how fast things are loading. So you can see I was able to, it loaded these in 2 batches. It's loaded 1.2 billion in the first batch and 1.5 in the second batch in roughly tens of seconds. So if we just do a sum and sum of those numbers, you can see we loaded 2.8 billion rows and it took about 100 seconds. And so just doing the math for you, that's about 28.5 million rows per second. That's pretty darn fast, right? 28 million rows a second. It can handle most of the use cases that we've run across. But what if you wanted it to go faster? So let's go over to our S16. So an S16 is actually a 16 unit cluster. So it's about twice as big. And a unit is 8 vCPU and 64 gigs of RAM. So it's 8 times that amount in terms of cores of memory. So admittedly, these are fairly reasonably large clusters. In our world, we consider them about medium. We have many clusters who run an S2 and S4, but we have some clusters who are running S40, or even up towards of hundreds of units, hundreds of nodes. And so in the S16, let's see how fast it runs here. It's running the exact same pipeline. It's just doing it on more machines that I've scaled out. And you can see, 2.8 million rows, same number of rows, but it did it in roughly half the time, even a little bit less than half the time, getting up to about 75 million rows per second. The key point here is that it's a distributed system, and if you need to scale to more performance, you can increase the size of the cluster, and the performance goes linearly with the increase in nodes. So making it easy for you to scale your cluster as your business scales, get the power you need, whether it's for ingest or query or whatever operation you're trying to do, the system scales with you as you need it. Now, you might ask, well, how hard is it to scale? What kind of operation does that look like? Well, let's say I wanted to scale my S4 cluster. I would just come over to the portal. You click this edit button. So currently in S4, and I could just simply select S8 and say update size. Now it takes a few minutes for it to go and add the new nodes and rebalance the system, but all of that's an online operation. We don't take anything offline. So you can continue running your workload while it's doing that scaling. And when it's done, your workload just takes advantage of those new nodes. All the data is spread out and evenly distributed, and away you go using the power of your new system. So that's the power of pipelines. Millions of rows, sometimes even tens of millions of rows per second, all with a single SQL statement. And this isn't a one-time load. This will actually do continuous ingest of data. It'll look for new files or new items in your queue and continually bring them in as new data arise. So you just keep that pipeline running as long as you want it running. If you want to pause it, you can just say stop pipeline and it stops. And if you're done, you can simply drop the pipeline and it goes away. So no third-party technology to install. Very simple, all built in. Metadata is built into the database, so it's easy to manage and easy to see what's going on. Now, the one caveat I will say is that I did deliberately make this a fairly simple table, right? Not everyone's going to see the tens of millions of rows per second that I saw. You know, I made it deliberately simple because I want to make it impressive for the demo, but I want to be clear that like your mileage will vary on how fast you can get based on things like how many columns you have, how wide the table is. If you put in a shard key, that has an effect. But as you can see, like you can scale the cluster to whatever power you need. And even if it was, I put in and I made it 10 times bigger and it was dropped to 20 million rows per second, it's still a fairly impressive number, and our ability to load is one of the crown jewel features of our product, and something that a number of people use us for. So that, I'm going to bring it back to finish my presentation and to see if there's any questions about SingleStore or the product or anything folks want to know.
Awesome, Rick.
Yeah, that was great, Rick.
I'm real curious too about the ACID compliance. Can you give us a little feel for that?
Sure. And the answer is pretty simple: is that we're ACID compliant, right? That we have atomicity, we have consistency, we have a read committed isolation level, right? And we maintain our durability by keeping 2 copies of the data at any given time in the system, right? And even though the data, when it loads, it loads into memory, and we keep in 2 copies of memory, but it's also sent to disk on the local SSDs.
Nice, nice. And I love the ability to be able to do upserts as opposed to just inserts. It's always been the bane of our existence when we moved away from true relational databases to parallel databases, and you had to always just do insert.
Yeah, that's one of the things about SingleStore is that we can do upserts pretty much faster than anyone else, and we can do it as part of that create pipeline statement that you saw. You can just say on duplicate key, right, do an update, and it figures it out and does the update without slowing things down too much.
Let's see, we got a couple of questions in the Q&A instead of the chat. Swami asked, Rick, does the ingestion pipeline have change data capture capability?
So our pipelines are more for ingesting like data, like files or queues. So it's not quite, we don't use it for CDC, but we have another technology that we leverage that can CDC data in from Oracle or SQL Server, MySQL, Postgres, like pretty much all of the basic relational databases. And so that's how we recommend doing CDC in.
Awesome. And then Francesco asked who your competitors are, big and small.
So the interesting thing about our competitor space is that there's competitors that are more the OLTP databases, and there's competitors who are more on the data warehouse. They all try to play in this data intensive space, but it's difficult because they often only have half the story, right? If you go back to my picture. So you see people from the analytical side, either on the on-prem, the Teradata is right, and then the cloud side, you see the big queries and the Snowflakes and the Redshift. They try to play in this space. They have great query engines. They're distributed systems that can do fast, complex queries, but they can't do the low latency and the high availability and the fast lookups. And then on the operational side, where you have your Auroras and your SQL servers, and look, I spent 12 years at SQL Server. It's a fantastic database, no question, but it's a single box database. It doesn't have scale out, and it struggles. It'll struggle compared to us on the analytical capabilities because it doesn't have that ability built in like we do. And so we see people from both the database, operational database side and the data warehouse side trying to play in the space. But when they're talking about a data intensive app that needs the capabilities of both, there's no one quite like us.
So something that kind of, when I was doing a review on you guys, and then as you were walking through the front end of your presentation, it kind of struck me as like, are these guys cracking the nugget that HANA was trying to do?
Yeah, our story is actually pretty similar to HANA. We have a few people who joined us from HANA. So yeah, I think there's a similar story there. I think I would argue our technology is superior, but I'm sure any good product person will say so. But yeah, they were doing something similar, trying to combine the abilities of a row and a column store and trying to solve for those data intensive apps.
Yep. Very good. Fantastic product. Great technology.
Yep, we're
I
excited.
have one question for you, Rick. So I know you had given us a link to share with everybody, which we've put in the chat, which is a great way to try the managed service for free. So do you generally see that people are, like, your customers are primarily using your managed service or your software offering?
Great question. So we started our history as a software company. That was back in about over 10 years ago. And that's primarily how we sold our product up until about 2 years ago. But we've seen a pretty significant shift in the demand for our managed service. And over the last 2 years, we went from 0% on managed service and 100% software till we've flipped over, and it's over half our business now is in the managed service, and a growing percentage of new deals are continually more on the managed service. Really, we're seeing the shift to cloud as a real thing, and it's happening now. And my suspicion is that over the next couple of years, we're going to see much less people buying software and far more people buying the managed service.
Okay.
Rick, what's this typical time to value for your customers once they buy your product?
It really comes down to how fast they can build their application, right? Which is it's sort of more on them. But generally, the kinds of value that they see, honestly, the numbers are almost mind blowing. Like, we'll see them get 10x, 100x, sometimes even 1,000x performance increase. Often we'll say 100x because 1,000x sounds too fantastical and no one believes us. But they'll drop from a loading time that took 24 hours to they can now do it in 20 minutes, right? Or queries that were taking 60 seconds are now a sub-second, right? And measured in milliseconds. That's the kind of value for people to see. So once they do the evaluation and they see that kind of gain, then we usually can't stop them from taking the product and trying to get it in production as quickly as possible.
Fantastic stuff here.
Yep, really good. Great presentation too and demonstration.
Anybody got a question out there to throw at Rick?
I think they
Stump the presenter.
those are a couple good ones that we had, but
Yep.
thank you for joining us this year, Rick.
Yeah.
I really
Glad to be
appreciate
here.
it.
This was a lot of fun.
Yes.
And I see,
Come back and do it again next year.
Yeah.
yep, and I see Julie's out there. So Julie, thanks for facilitating all of this. And we'll be back with you, and hopefully we'll see you next year on this, but hopefully we'll have some good things to do with you in 2022.
Yep.
Thank you very much.
Thanks
All right,
so
Rick.
much, Rick. We
You
really
have a great day, sir.
have a great
Kalia, what's up next, baby?
Okay, let's see. Next up, starting at the top of the hour, which for us here on Mountain Time is going to be 10 a.m., we are going to roll on over to our good friends at Elation.
Nice.
So I am going to share just kind of an intermediary slide, and this is everybody's refill your coffee, go get your bio break on. If you're like me, you're grabbing a snack. I just want everybody to know every single time we take a break, I'm going to grab a snack.
Human garbage disposal. Kalia. So
Because she burns 1 million calories a day.
yeah,
how we
that's
keep it
true.
going. That's how we
That's
keep it
true.
going.
Okay, we'll
all
see
right.
everyone at the top of the hour. Hopefully
Thanks,
you'll stay on
everybody.
and join us. Take care.
Thanks. Take care, Rick.
Bye.
We'll be right back.